My name is Pronoy Biswas and I am going to teach you the introduction to organic chemistry, and I am a third year undergraduate student of the Department of Chemistry at IIT Kharagpur. So, what is organic chemistry? First, we have to realize this thing. Organic chemistry is the study of the organic compounds that are derived from natural sources and also from man-made or synthetically produced organic compounds of carbon. So, why has it become a very interesting part of this course, this organic chemistry? It is because whenever we look from our day-to-day life or point of view, we see that there are a lot of compounds like the fiber, the food we eat, the medicine, and our lot of other important and vital things that are necessary. So, how did this organic chemistry actually came into the picture? Till 19th century, it was believed that all compounds that are essentially made in the nature are organic compounds, and no man-made interaction can be there. So, in 1810, a famous Sweden chemist known as Berzelius proposed his theory of vital forces, or the hypothesis of vitalism. So what is it? He proposed that all the organic compounds that are basically derived or present in the nature are always to be formed in nature by some natural source. No man-made thing can make it. So it was going well with this theory. Then suddenly at 1828, a German chemist known as Friedrich Euler accidentally produced urea from ammonium cyanate, which was essentially an inorganic compound. Then, after preparing this thing, he wrote to Berzelius stating that how can I make an essentially organic compound from an inorganic precursor? After a few years rather, in 1845, we get another chemist known as Kolbe. He produced acetic acid from inorganic precursor. Similarly, in 1850, Barthelot produced a lot of organic compounds from inorganic precursors. Hence, it is providing a natural death of this theory. Hence, towards the starting of 20th century, we are progressing towards more scientific and logical understanding of how these compounds are coming in the picture. So, to understand these theories, we came up with the understanding of valence bond theory, linear combination of atomic orbital, hybridization, the molecular orbital theory, and recently with the density function theory. So, when this bonding of carbon came in picture, we have certain parameters kept within us, that is the oxidation number, the formal charge, and the electronegativity. So, assessing all these features, we come to a clear conclusion that these organic compounds which we are going to get in nature has to have some basic theory or principle in which we can make them. So, accessing all these theories, we come to a picture that out of 114 elements present in the periodic table, we have carbon bonded to hydrogen, sulfur, boron, oxygen, nitrogen, phosphorus, silicon, and the halides, that is fluorine, bromine, chlorine and iodine. These are majorly apart bonded with the carbon. Also there are metallic parts also, like the transitional and the inner transitional elements. They also bond with the carbon, forming important class of compounds known as the organometallics, and they serve a part in our catalyst chemistry, and also many synthetically derived important compounds. So out of this we have realized that this organic chemistry has been derived from a class of general chemistry, which was later on separated from this general class to a more specific, oriented towards the carbon chemistry. So in other words, we can say that it is more like a study of carbon along with the other elements. So I am stopping the lecture here. Thank you very much. Enjoy.